Welcome everybody to Math 60. This video lecture is section 3.6, which is about comparing fractions. Which is bigger? So we know that bigger with numbers means more to the right on the number line. There's our number line, 0, and I'll put down a couple of numbers, -7, -3, 2, and 5. And we can do some comparisons here, but ultimately what it comes down to is your number is bigger if it's farther to the right on the number line. Decimals work really well on the number line, -5.2. All right, I know exactly where that goes. I know where 8.3 goes. It's just to the right of 8. The challenge comes from fractions. Where does 119 over 22 go on the number line? Now you can figure that out through long division, which I never learned. I don't really, I do my long division a little differently, but I've never divided 22 into 119. What I do is I puzzle my way through it. I'm just going to show you. I say, well, 22 times 5, that's 110. So that's not quite enough. And 22 times 6 is going to be 132. That's too big. So I know it's going to be between 5 and 6. Generally, that's enough for me. And if I want to be really picky, that's 5, which is 110, plus 9 more of those 20 seconds. All right, because if I take this number and I multiply it by 22, I'm going to get 5 times 22 plus 9 over 22 times 22. That's the distributive property. I already found out that 5 times 22 is 110. And if I remember how I multiply a fraction times an integer, you multiply the top times the integer. Or in this case, you get to cancel the 22s. And I get 119. Right, so now I know about how big it is. How big is 9 over 22? Well, I do kind of the same thing. It's a little less than half, right? Because 11 out of 22 would be half. So this is about 119 over 22 is about 5 point. I'm just going to get something a little less than a half. Let's do 5.48. Of course, if you want an exact answer, we do live in the age of calculators. And according to the calculator, it's actually 5.40909 forever and ever. So I was pretty close, but close enough to know where to put it on the number line. Now, I went through that kind of fast because that's not actually the focus of this section, but I wanted to let you know fractions are tough. It's hard to know where fraction goes on the number line. And if you don't have a calculator, you kind of have to puzzle your way through it. And if you do have a calculator, it's super quick and easy. So calculators are absolutely fine to see about how big a fraction is. They're also fine for comparing fractions, but I do want you to learn how to compare fractions without using a calculator. We'll do this. Not doing that kind of recording. Okay. So instead of 19 over 22, let's compare 119 over 22 to 57 over 13. Which is bigger? And let's do it without a calculator first. Actually, we might still end up using a calculator, but let's do it without just getting the decimal versions. Okay, so the challenge is don't try to compare fractions unless they have the same denominator, which is the bottom. If they do have the same denominator, you just get to compare the numerators. So to compare fractions that have the same denominator, you just compare numerators, which is the top. If I want to compare 8 over 19 and 13 over 19, which one of these is bigger? 13 over 19, because 13 is bigger than 8, and they're both divided by the same number. Right, so that's as straightforward as just comparing integers, because you just compare the tops, which are the integers. So that might say, if I'm trying to compare fractions with a different denominator, the first thing I need to do is make them have the same denominator. You need to compare fractions with different denominators. Step one is to find equivalent fractions. So I'm going to use that word, that term, find equivalent fractions with the same denominator. Remember, an equivalent fraction is just a fraction written a different way. So we have 119 over 22. And we have 57 over 13. The easiest way to get equivalent fractions with the same denominator is to multiply by a fraction made of the missing piece. I've got a 22 in the denominator. I'm missing a 13. So I multiply by 13 over 13. And the 57 over 13 is missing a 22, so I multiply by a 22 over a 22. What's the number 13 over 13? 1, so I haven't changed anything, because you multiply by 1 and nothing changes. What's the number 22 over 22? 1, so I haven't changed anything, because when you multiply by 1, it doesn't change anything. So these two fractions that I haven't multiplied out yet, they're the same as the 119 over 22 and the 57 over 13. So this is where I'm probably going to use a calculator anyway to do these multiplications. Remember, when you multiply fractions, you multiply the tops and you multiply the bottoms. So we could do this by hand, but it's Monday at 8:16 and I'm sleepy. So 119 times 13 is 1,547. 22 times 13 is 286. Right, this fraction is equivalent to 119 over 22. 1547 over 286 is equivalent to 119 over 22, because all I did was multiply the top and bottom by the same number. 57 times 22 is 1,254. And I already know what the denominator has to be because the whole point was to get them to be the same denominators. So which is larger, the left or the right? The left, because 1547 is larger than 1254, and they have the same denominator. And that means that 119 over 22 must also be larger than 57 over 13. And how do you check? Well, I want you to develop this skill, partly because when we work with variables like x's and y's, sometimes you still have to get your fractions to have the same denominator. Only we're not working with numbers, so calculators don't help us. So this is an important skill to develop, but you can check by finding decimals. We saw that 119 over 22 is 5.409, etc. And 57 over 13 is 4.38, 5, etc. And so, yep, that helps me see that I was correct when I did my arithmetic. So it's a good idea to check. I want you to check with every one of the ones you do on your worksheet, but try really hard to do it by hand first. Any questions about that process? I started with different denominators. I said, I don't like doing comparisons if they don't have different denominators. Mathematicians do this all the time. They say, I don't like the question you gave me. I'm going to change it into a question I want to do. And so we do some math to change it to a question that I like, and becomes very easy. And that tells us what the original comparison was, and then we can check it with the decimal. All right, let's do another example. If you're reviewing your textbook, it's always a good idea to review your textbook, but you're going to notice that it does it a little differently than I'm going to do this one. So let's compare 17 over 24 to 23 over 36. I don't know which of these is bigger. I'm just kind of making it up. So your book would say, find the least common multiple of the denominators. If you remember how we do that, we count 24, 48, 72, etc. And we also count 36, 72, and there's 72. That's the least common denominator. And so your book would say, rewrite these fractions to have a denominator of 72. And that absolutely works. But there's a more straightforward way. That's the numbers end up being bigger. Well, let's go ahead and do it this way first. And then I'll show it the other way, and then you can pick which way you like better. So 24, to make it into 72, my missing piece is the 3, because it took 3 steps to get to 72. And 36, my missing piece is 2, because it got 2 steps to get to 72. In the previous question, I just multiplied 13 times 22. I didn't do a least common multiple, but that's because there was no least common multiple until I multiplied 22 by 13. They don't share any prime factors. So I can probably do this in my head. This is 51 over 72, and that is 46 over 72. So which of these fractions is bigger? 51 over 72, because 51 is bigger than 46. So 17 over 24 is bigger than 23 over 26. That doesn't sound right. 36, that sounds right. I'm familiar enough with fractions that I was like, wait a minute, if I wrote that denominator the other way. Okay, so the least common multiple, it can make the equivalent fraction part simpler. And I'm multiplying the left one by 3 and the right fractions by 2. Those are pretty simple multiplications. But sometimes finding the least common multiple is a challenge. So I'm going to show you that you don't need to find the least common multiple in order to get them over the same fractions. We still got a couple writing, and that's totally fine. Oh, and I can check these with decimals, but I'll let you check them with decimals. Okay, let's do the same question without using the least common multiple. Let's do 17 over 24 compared to 23 over 36. And I'm going to say in this time, I don't want to take the time to find the least common multiple. I don't have to, because I always know I can just do the missing part. 17 times 36 over 36, and 23 over 36 times 24 over 24. That's always going to work. You can always just multiply the denominators together. It's way bigger than it needs to be, but if we're going to use a calculator anyway, it's not that big of a deal. I get 612 over 864. And I get 552 over 864. And which one of these fractions is bigger? The one on the left, because 612 is bigger than 552. So this is not a calculator-free way of doing it. I probably wouldn't have wanted to do 17 times 36 in my head. When I use a least common multiple, I was able to do it just in my head. I'm familiar enough with that multiplication. But if you're not sure, you can always just pick the denominator that you get by multiplying everything together. And of course, if you're going to use your calculator, you can always check it by finding the decimal versions. But let's think about if I wanted to combine like x plus 1 over x and x minus 3 over x plus 2, right? These are different fractions and they involve variables, and we are going to get to this in this class. And it's the same idea. They need to have the same denominator, right? So you would have to take your x plus 1 over x and multiply it by what is missing, which is the x plus 2 over the x plus 2. And then you have to do the x minus 3 over x plus 2 and multiply by what's missing, which is x over x. And now they're going to have the same denominators, and you can start working with them as fractions. So that's one reason we do this in the age of calculators. Is to start to build up these skills so that they also work for fractions. But this is an aside. This isn't going to show up for a while. No, you'll be ready for it when we get there. I just want to, I put it there because what I've noticed so far in this class is no one in this class is overly reliant on a calculator, but at a certain point, you might get to the place where you're like, oh, I'm just going to use a calculator. And if this is that place, I still want you to learn the process because you're going to have to be able to use it when calculators don't help you. Okay. Now, there are a couple other wrinkles. Let's compare 192 over -3 to 7 over 85. I think we can do this without even getting them over the same denominator. Why do I think we can do that? Exactly. It has to do with the negative. This is a negative number on the left. That's a positive number on the right. Every single positive number is bigger than every single negative number. Boom. Because positives are bigger, right? Farther to the right than negatives. So if you're just asked to compare the size of those fractions or to figure out which fraction is bigger, you don't have to do more work than is necessary. It's still important to recognize that even though it's a fraction, it's a negative number, and therefore it has to be smaller than a positive number. And the last thing I'll say in this section is to be careful. If I compare 4 over 7 to 2 over 3, 4 is bigger than 2, and 7 is bigger than 3. But that does not mean that 4 over 7 is bigger than 2 over 3. Right? Just because the tops and or the bottoms can be compared doesn't mean one fraction is larger than the other. In this case, 2/3 is actually bigger than 4/7. And we can check that because 4 over 7, I'm going to multiply by the missing piece, which is 3 over 3. And 2/3, I'm going to multiply by the missing piece, which is 7 over 7. And I get 12 over 21 compared to 14 over 21. And sure enough, 14 over 21 is bigger. So 4/3 is bigger. Oh, sorry, 2/3 is bigger than 4/7. And on the other hand, if I were to look at 5/7 is actually bigger than 2/3. So when you compare fractions, you cannot look at, oh, both of these are bigger or both of these are smaller. You'll only compare them when they have the same denominator. All right, that wraps up section 3.6.